Thank you very much. Welcome to ContainerDays. My name is Bohne. I'm a specialist solution architect for OpenShift at Red Hat. So if you have any questions around OpenShift, feel free to ask me. I have a kind of infrastructure background and one small step into the developer world. So, and today we want to talk about operators. If you like, follow me on Twitter at @Bohne. Let's start with the application lifecycle. If you think about operators that also have something to do with application lifecycle. So stateless applications on Kubernetes is quite easy, but stateful application is hard. And for stateless, you can simply write your Kubernetes YAML files, you can write your Helm charts, you can write customize, and you can simply deploy your application, you can scale it up, scale it down. Patching and updating is simply redeploy your application, so not a big deal. But for stateful application, it's harder. You deploy it, you maybe have to set up some kind of clustering update process. You have to be careful about your data, so update your version of the database. Is it consistent? Everything works well. If you want to rebalance because you add more nodes or pods, to your stateful application, and for that you have usually some app service guys, SRE teams, or folks that are doing that job. And the idea with an operator is to operate all those tasks with software. So you bake your knowledge of your stateful application, how to deploy it, how to scale it, how to operate it, how to backup it, how to recover it in software, and this is an operator. So basically, the operator is managing the whole life cycle of your stateful application. So how to use an operator? It starts with kind of an administrator, deploy the operator itself, and then a user or administrator itself, doesn't matter, talk to the operator via an API and say to the operator, hey, please deploy something for me, a database or whatever. And then the operator knows what they have to do to deploy the database or stateful application in an HA fashion way with backup and recovery and so on. And important here for the operator piece, this is at the end a control loop and compares the desired state, what is declared via the API, and the current state, and is responsible for making the current state come closer to the desired state. So it's something change on both ends. The operator takes care of that both ends match together. If something changed on the API level or something changed on the deployment, the operator have to take care of it. And this piece of software is called the controller. And for the API part, we're living in the Kubernetes world. Of course, we use the Kubernetes API. We don't want to implement our own API for every operator. With Kubernetes, we have an API. We use the Kubernetes API. And this brings us to both two components. On the one hand side, the controller and the API extensions, and we called custom resource definition. Custom resource definition is a way to extend the Kubernetes API to create new objects. How does it work? Of course, custom resource definition is a YAML object. You apply it to your API server, and then you have a new object available in your Kubernetes world. Here, for example, a custom resource definition to manage my cars via the Kubernetes API. I'm a little bit car addicted, so I want to manage my car via Kubernetes API. I create a custom resource definition to manage my car. I say the kind is car, the list kind is car list, and its scope is namespace scoped, and I apply this to the Kubernetes service, Kubernetes API. And then I have to apply the custom resource to it. The custom resource is the actually object. So here a car, a BMW, with a date of manufacturing, type of engine. And then you can simply run OC get cars or kubectl get cars, kubectl edit, delete, patch, whatever. Everything with you can do everything with every other object in the API. You can also add some more columns if you like, so some additional print columns. You may know this minus or white, and then you can say, hey, which columns should be added from the spec part to have a better overview. And then you have your API working. Back to the controller. Controller is only a piece of software. How do you deploy a piece of software on Kubernetes? Via a deployment. So your operator is basically a container image, and you deploy it via deployment config on your Kubernetes cluster. How does it look like? We have our picture again, and this is everything running on Kubernetes. And the administrator write a deployment config, create a CRD, and then your operator is running. The user create the CR, and then the operator with his control loop seeing, okay, there's a new API object, I have to deploy something, and this, of course, all Kubernetes objects. But think a little bit out of the box. Our operator is deployed, the user creates an CR, and then the operator can also talk to an external API that is not located on your Kubernetes cluster and say, hey, please provide me an database on AWS or on GCP or an Oracle database or whatever. And then the operator writes only back into the Kubernetes namespace the secret with the credentials and then service with an endpoint to your actually database. Just to think a little bit out of the box. And what is the pattern? So again, we have the API with the custom resource, and then you write everything from your application state into the custom resource. The controller is watching those events, so it's listening to the Kubernetes API and watching events on those custom resource objects. And on the other hand side, we have this reconciliation loop, I hate this word, and takes care of what is defined into the custom resource and what I have to deploy. And if something changes on one side, the operator takes care of that everything match perfectly together. And what is the easy way how to build an operator? There are a bunch of frameworks out there available. For example, Cube Builder, Kudo, also what I find out in shell operator, so you can write your operator in shell. If it makes sense, I don't know. But today I want to talk a little bit about the operator framework. And the operator framework provides an operator SDK that makes it easier to write your own operator. Currently we are supporting 3 different languages. One is Go. It's well known, I guess. You can write your operator in Go. And also we're supporting Ansible and Helm. So you can put your Ansible playbooks and roles into an operator, and then your Ansible playbooks is running if something is changed or someone creates an CR, or your Helm charts. So you use your existing Helm charts and putting into an operator. With the operator SDK, we have some kind of capability levels. So which capability levels can support an operator starts from basic installation. So I have here an operator is only capability level 1, then it can only run basically installation. No updates, nothing more, install and deinstall, and that's it. That's the good starting point. But then you want to run maybe also to reach phase 2, that's supporting seamless upgrades, and then your operator can manage your application, upgrade your application that is running. And with Helm and Helm operator, you can only write phase 1 and phase 2 capability level operators, because Helm is not a programming language at the end. If you want to write an operator who supports more capability levels, then you have to pick Ansible or Go. If you want to write an operator with a full lifecycle, so with backup and recovery features, or with deep insights for metrics and alerting, or in full autopilot mode that your operator detects, hey, my database is running out of disk space, then it enlarges the disk, or it runs out of CPU and memory, then it starts maybe more pods or allocate more resources to your pods, then you have to use Ansible or Go. Of course, Ansible is not a programming language. You can do a lot of stuff with Ansible, but if you really want a programming language, I'd definitely recommend to use Go. We're also working with the operator SDK to support Java, but this is, I would say, on the roadmap, or it's work in progress in the community. How does it work? With the operator SDK, you have simply an operator SDK binary, and you say, hey, I want to write a new operator. And then it creates everything for you what you need to create an Ansible, Go, or Helm operator. It creates a deployment config for your operator. It creates all roles and cluster roles and role bindings and the service account and everything what you need to run an operator and use it. And of course, it creates also an example custom resource definition for you. And here, for example, how to create an Ansible operator. So it creates an empty Ansible role for you. It creates a mapping file. It creates a custom resource definition and everything what you need to deploy the operator. And how does it look like in detail? In the controller part, the SDK takes care of those event watchings. And then you have a mapping file, and the mapping file describes on which CRD, which playbook should be run. Here, the example from the mapping file, you describe which CRD is created or is in use, and then which playbook or role have to call if something changed on the CR. You can also plug it to an existing CR. For example, you can write an Ansible operator to watch all ingress objects and add some custom certificates or whatever. Then you write everything, and then at the end you have your metadata, the information how to deploy an operator, deployment config, role bindings, all those informations, and you have to container image, where the Ansible playbooks, or in case of example of Helm charts are baked into the image. And then you have to build those images with the operator SDK. It's quite easy. You have simply a make file. You can simply write make docker build and docker push, and then it pushes the actually operator image. And the second image is the operator bundle. And the operator bundle is a container image what everything contains from the information how to start an operator, the custom resource definition, so basically the operator deployment itself, and the operator image is your controller, where your logic is baked into. Hope that's clear. And all those images, of course, are pushed to a registry, for example, cray.io, and then how to ship it to your cluster. And for that, in the operator framework, we have the operator lifecycle manager. And basically, the operator lifecycle manager is an operator for operators. So usually you have more than one operators in your Kubernetes cluster or OpenShift cluster, and then you want a manager who manages all those operators, and this is the operator lifecycle manager. If you want to know more in depth about the OLM, more than I explain in a second, then visit the talk from my colleagues in an hour, exactly here on that stage. And basically, the operator lifecycle manager fetches the bundle, so all metadata information, all information how to deploy an operator, and deploy the operator if you like. It's basically for the upstream Kubernetes world, you can go to operatorhub.io, and then you see a bunch of operators that are provided from several ISVs, from Instana for application monitoring, or Dynatrace, or some storage vendors providing operators to connect your Kubernetes cluster to your storage system, and a lot of more. And if you are using OpenShift, then you have this operator hub into your OpenShift cluster. And of course, if you're running OKD, you have also this operator hub in your OKD cluster. And this OLM also takes care of updates. So an operator is a piece of software. So you write your operator, you're finding bugs, you write a new version of your operator, or maybe you need some more features or want to support a newer version of your application, then you have to write a new operator. And the OLM takes also care of updating those operators on your cluster. So you publish the operator bundle and your new version, and then the operator, the OLM recognize it, and then you can auto-apply it or approve it by hand. And what you also need is some kind of dependency resolution. For example, if you write an operator who needs who manage an application, and the application needs a CockroachDB into the background, then it can be also say in your operator bundle, okay, I have an operator dependency to another operator, please install another operator too. And then you have this dependency. It's like an RPM dependency. So if you have an RPM package with an HTTP web server and you install it on your Linux box, then you have some more package to install. And this is the same with this operator dependency. And much more, but I would say these are the key features. So the administrator looks into the operator hub, what everything is available, and then it picks one operator to install. And then the operator is available in your Kubernetes cluster. Keep in mind, there are some operator scopes you might have to know. Some or less operators supports only OwnNamespace. So your operator is running into the same namespace where your application to manage is running. Or SingleNamespace, then you have a namespace where your operator is running, and in another namespace is the actually application, the stateful application is running. One namespace. Or you have multiple namespaces, so basically your entire cluster, you deploy your operator, and the operator is watching for a custom resource in every namespace on the cluster. And if the CR is coming up in one of those namespaces, then the operator recognizes it and do something. And then after installation, the operator is available in one namespace or in every namespace on your cluster. Then the user can create a custom resource, and the application is created from the operator itself. There are some ideal use cases for operator development and less ideal use cases for operator development. This is more, I would say, the weak part, because always depends on your environment and your application, and of course, of the amount of deployments. Ideal use case for an operator is, of course, a stateful application. So if you need an instance who manages your application, then the operator is the right place. But it could also make sense if you have a kind of microservice application that is very complex and deployment is not easy, to write an operator for it. Or if you have a stateless application and you have it deployed not only once, because you want to deploy it many times in every plant of your company or whatever, then it could also make sense to write an operator to have an easy deployment process. And maybe an easy update process for your stateless application. Sometimes the init containers and some hooks in Kubernetes are not enough to manage your application automatically. Then it could make sense to write an operator. Yes. Let's do a little demo about writing an operator and deploy it on an OpenShift cluster. I prepared a video for that because I was not confident enough after 2 years sitting at home to presenting a demo live. So first of all, we log into our container registry where we can push our operator images. Then I'm logged into an OpenShift cluster, and then I create with the operator SDK an Ansible operator. And then we have a bunch of objects. So we have a lot of objects here, the custom resource definition, the information how to deploy the operator, role-based access management objects. You need several role-based access management. You want get only access to objects that the operator is really managing. So you don't want to say, hey, my operator is cluster admin and do everything. You really want to say, okay, this is an operator, and the operator creates a deployment config and creates, for example, a persistent volume claim. And this is everything prepared into the role-based access management. And of course, it creates some playbooks for you. It creates an empty Ansible role if you like. So if you have your existing Ansible roles, you can copy it into. And important here is this watches YAML I mentioned before. This is the mapping between the custom resource definition and your Ansible playbooks. And then I'm adding here a simply example playbook into the role, just simply a debugging output to print all variables. And then I build my operator image, so the controller. So it's quite easy. Then with the operator SDK, then you can simply deploy it on your existing cluster. So during development, it makes sense to deploy your operator, test it, and play around. Then you can simply run make deploy, and then you deploy your operator, and then it applies all objects you need to run the operator on the cluster. And then we watch if the operator is running. So this is my sample operator, continuous creating. It's running, but not fully ready yet. And then the controller is ready. And then I apply this example custom resource to my cluster. And here in the spec part, I added simply foo_bar as a spec. And here we see the log output of the Ansible operator. And all what you write into the spec part of your custom resource is forward to your Ansible playbooks or to your Helm charts. And then you can use those variables to do something. A lot of more output. And then if you want to undeploy it because you are ready, you can simply delete your custom resource and can run make undeploy. Takes a while to delete everything. Get the finalizer ready. Delete namespaces, delete custom resource definitions. And then let's do it via the OLM. So we create our bundle. And for the bundle, there needs some more information, name of the operator and description, the provider, that's me, and an URL with some documentation or whatever, or when you create some GitHub issues. Some keywords for the operator, that's easier to find in your operator hub. Of course, maintainer information. You want to blame something, it doesn't work. Someone, not something. Then we create this bundle image with all the metadata information. And then is the important part, all the bundles you have is putting into an index image, and the index image is populated to the operator hub, to the OLM, to the operator lifecycle manager. The index image is kind of a catalog. And then we added those catalog source to our Kubernetes or OpenShift cluster and say, hey, here's another index image available with some operator bundle informations. Please make those operators available in my cluster. Then the index image is starting. It's basically a database with all the information. And it's running, but not ready yet. Now it's ready. And now we switch to the OpenShift UI. And we can take a look into our global configuration for the operator hub. And we see there's a new source. So a new source for our own operators. My catalog source is basically only one operator in place. And if we look into our internal operator hub, we have our own operator catalog available. With our own operator, I know, no fancy image. Just for the demo purpose, we can install the operator. And here you have this install mode. This is the one I mentioned before about the operator scope. So for which namespace the operator is responsible. And this is not a decision to decide during operator installation. This is a decision from the operator developer, which operator scopes the operator supports. And then we install the operator. And what happens in the background is it takes the bundle image export everything from the bundle image, deployment config, custom resource definition, role binding, service account deployed on the cluster. In the deployment config, we have the information about the operator image, and the operator is deploying. And if the operator is available, we see in our UI that, that the operator is installed, and then we can create an instance of our operator, OKD and OpenShift providing a form. If you like, you can add your own fields, or you can simply apply the custom resource to your cluster, and then the custom resource is applied, the operator takes care of it. After a while, here I'm getting a little bit nervous because it's not getting ready, and now it's in status condition running. Let's take a look into the CR, and in the status field, you see the Ansible operator is writing the whole Ansible status, so how many tasks are completed, changed, okay, or with failures. Let's take a look into the operator log again, and it's basically the same what we saw before, just in the OpenShift UI. That's it. If you like to learn more about Kubernetes operators, feel free to download this O'Reilly book, Kubernetes Operators. Use the QR code or the download link, and then you can download this O'Reilly book, Kubernetes Operators, for free. I would say thank you, and if you like some of those sticker bundles, use the QR code, go to the site, fill out your home address or your company address, and then Red Hat is sending some stickers to you at home. And thank you very much. I'm just in time, perfect. If you have any questions, 3 minutes left, I guess.
Okay, what to do first? Questions, applause, questions. Okay, I saw a first question. It was over there. I think how do we do the thing with a microphone?
It just works. Hey, thank you first. And which container was exactly responsible for running the playbooks? And does it scale to multiple runs?
Sorry, I don't get the second question.
Does it scale to multiple runs in parallel?
Yeah. So first, the controller was responsible to running the playbooks. So the controller image at the end, and the playbooks is running inside. And of course, with Ansible operator and scaling, it not runs in parallel. It runs all playbooks for all CRs sequentially, so after another. And this is not the easy solution for high scale. So if you want a high scale operator, then please use the Go framework. And in the talk tomorrow from Michael Gash from VMware, you want to learn more about API and timing problems. And if you have high scale volume, then you might run also those issues about timing and CRs are changing. And then a right programming language like Go is, I would say, the better choice for that. Hope that answered your question.
Do we have more questions? Do you have more questions? Okay, seems like everything's clear.
Cool, thank you very much. Have a great day.
Thank you, Robert.